first glance at number 10. It's one of those Roman numeral tricky ones. So I'm going to cover that up right now. Let's just look at the situation. Several forces act on an object. Okay, I'm going to draw that. Here's my object. Okay, but the object is in equilibrium. I think most people know that that means that the forces balance. Like they say if you have bad sinuses, it throws your equilibrium off, or if you're dizzy, so it makes you unbalanced. So yeah, if you want things to be in equilibrium, it just means balanced forces. So like force 1, you'd have to have a force 2 in the opposite direction. And we don't know what any of these forces are. It just says an object and forces. So like force 3 and force 4 would have to balance out. I think most of you can see pretty instinctively this thing's just balanced. Now, the question is why? Well, remember about net force. Hopefully remember acceleration equals net force over mass. And the mass isn't going to change at any point. It's just that dot. That means acceleration is directly proportional to net force. And if all your forces are balanced, let's look at this. Let's say F3 right here. Let's just say that's 7 newtons. Guess what F4 is? 7 newtons. I'm not putting negatives with the arrows, so that just means F4 minus F3 is 0. Okay, in the y direction, and then these two would be the same, whatever they are. So they balance each other out. So that just means that no matter what happens, whatever force you have on it, because it's in equilibrium, you're going to have one going the exact opposite way. It's the same amount. So your net force right here, net force will equal 0 no matter what. Well, guess what? If your net force is 0, guess what your acceleration is going to be? 0. So just because graphs are awesome, that means if you have acceleration versus time, that means that your acceleration is 0. But what would that mean about velocity versus time? Well, if that's the bottom of the ocean, that means this would be a parking lot. So that means your velocity might either be this or this, but it's going to be constant, which would mean your position would change at a constant rate. So something like evenly spaced, something like that. So let's look what the answers are. 1, it has an acceleration of 0. Yes, that is always true, because what this says must be true. 2, my battery's dying. The net force acting on it's 0. Yep. 3, it's at rest. Wait a second. Now it can be at rest. That would make sense. Everything's kind of balanced out, like, balancing. Not doing a very good job of that, but balancing something. It could be at rest, but does it have to be? Because it's moving with a constant velocity. Well, look. It could be moving with a constant velocity, because if your acceleration is 0, that could be your velocity. That could be your velocity. One does not know. So it's kind of just not speeding up or slowing down. That's entirely possible. So these two are question marks. So the only ones I would say must are 1 and 2. And so your answer would be